In Part 2 of Lecture 2, we will look at an example of a conditional loop. There is nothing magical about the magic number game. One player picks a number, for example, between 1 and 100, keeps it to him or herself, and then the other player tries to guess it, guided only by clues of whether the guess that was made is too high or too low. The idea is to guess the number correctly in as few guesses as possible. Now, it's pretty obvious that you cannot use a counting loop for this, because there is no way in advance to know how many times you're going to go through it. You're going to keep guessing over and over again until the guess made matches the number that was picked. We're going to have the computer pick a random number for us, and that is going to require us to learn a little bit about library functions as they exist in Java. Most modern programming languages include a series of libraries that provide users with software that can do certain common tasks, such as input and output, things like square root and some trigonometric functions. And system out println and keyboard next int are examples of exactly this. We've already seen the import command, and what import does is allow us access to a series of libraries of routines that are available. When we write in the program import java.util.scanner, it's telling us essentially where to find the necessary software, the necessary definitions for the scanner class. It is inside a directory called util, and it is inside the subdirectory where the various libraries for Java are contained. If we are looking to use the random number function, we're going to make a change to the import statement that we used. We'll right now import java.util.**, replacing the word scanner with a semicolon means that we will make available to us all the class definitions in all the subdirectories that are part of util. This is going to be a little bit more convenient for our purposes here. A class is a lot like a data type, but the big difference is that it is defined by a programmer and may be part of a programming language's standard package, so to speak. Classes need to be initialized before use, just as we did with keyboard when we wrote scanner keyboard equals new scanner system in. The random number function that we are going to use is called nextInt. Yes, just like the one that we used with keyboard. It is part of the object that we will declare called newRandomNumber. We begin the program as we saw before with import java.util.*. This means that we will have the classes available to us for both the scanner and for our new random number. We have the header for the class, public class magic number, and then an open brace. And we begin the program with a comment. The magic number game has the user trying to guess which number between 1 and 100 the computer has picked. We begin the main method, as usual, with public static void main, and in parentheses, string open close brace, args, close parenthesis, open brace to begin the method. Let's start by setting up our two objects, scanner keyboard equals new scanner system in. And now random, new random number equals random, and an open and close parenthesis, nothing inside, semicolon. We're going to have two numbers here to work with, magic being the number the computer chooses, and guess, what the player will choose to try to guess the magic number. So we have here int magic, comma, guess, semicolon. And we'll start this being the first try with int tries equals 1 semicolon. Let's begin the game. We begin with a comment. Use the random number function to pick a number. Magic equals new random number dot next int open parenthesis 100 close parenthesis plus 1 semicolon. New random number is the name of the object, and the method that we are using that belongs to it is next int. This is how we know the difference between reading in a number from the keyboard that's an integer and getting a random integer number to use in the program. Now we need a guess from the user. We have a comment, let the user make a guess, and then system out println guess with a question mark indicating we're looking for the user to write in a guess here. Guess equals keyboard next int, and now we're ready to go into the loop. While guess is not equal to magic, and we open a brace so we can have the loop in here, we have a comment, tell him or her whether it's too high or too low. If guess is greater than magic, system out println wrong, too high. Else, system out println wrong, too low. We don't deal here with the case of whether the guess is actually the magic number, because the condition for entering or re-entering the loop makes that not possible within the loop. We now have a comment. Let the user make another guess. System out println guess, and now guess equals keyboard next int, and tries plus plus means we add 1 to the number of guesses that has been made. If we've reached this point in the program, we know that we have found a guess that matches the magic number. So we start with the comment, the user won, tell him, her. System out println, right. System out println magic plus is the magic number, and we skip a line. Then we have a comment, tell the user how many guesses it took. The user will want to know that. System out println you took tries guesses. We now have a close brace for the method and a close brace for the program. We will be making more and more use of values that are true or false. So we will want to work with what we will call Boolean variables, variables that can be true or false. The type that we use for this is Boolean, spelled as you see here. And we write Boolean married equals true means that married is a variable that can hold either a true or a false, nothing else. And in this case, it's initialized as true. As you can see in the example here, somewhere later in the program, we can have if and in parentheses married, and below that, system.out.println quote, parenthesis quote, the employee is married, new line, close quote, close parenthesis, semicolon. Now that we are beginning to see Boolean variables, it becomes a good idea to be familiar with Boolean operators, operators that will work on Boolean values and produce Boolean results. Not, and or. The not operator in Java is an exclamation point, frequently referred to by Unix users and Linux users as a bang. Sometimes we want to test to see if the condition is not true. And the way in which we do this is to put an exclamation point in front of it. If married were not true, putting the not in front of it would change the false value to true. Then what we can do is write if, open parenthesis, bang, married, close parenthesis, system out println, quote, do you, unquote, plus, quote, want to bring a, quote, unquote, plus, quote, date, question mark, unquote, close parenthesis, semicolon. Frequently we'll find that there are two or more conditions that we have to consider in deciding whether we're going to follow one course of action or another. For this reason, we have operators for both and or. The operator for and is two ampersands right next to each other, as you see in the slide. The operator for or is two vertical lines. On a standard keyboard, this would be holding down the Shift key where you have the backslash. If I were to declare two variables, P and Q, P and Q would only be true if both of them individually were true. P or Q would be true if either one of them is true, or if both of them are true. It would only be false if both were false. You may have noticed in the magic number program that we ask the user for the number he or she was guessing twice in the program, once before the loop and one at the end of the loop. The one we have before the loop is very necessary because we test to see if the condition is true or false before we enter it even the first time. We still have to have it somewhere else in the loop because if the condition does not have the capacity to change, then we would be in the loop forever. Now, occasionally it proves to be more useful not to test at the beginning of the loop, but to test at the end. There are some loops that we will want to go through at least once. For this reason, Java gives us the do-while loop. And you see the syntax here. The word do, and then an open brace. We can now have as many statements as we wish. At the end, we have a close brace, a condition inside parentheses, and a semicolon. Unlike while, unlike if or else, it doesn't matter if there is one statement in here or 500,000 statements in here. We will always need to have it surrounded by braces. Let's take a look at the loop in the magic number program. We can rewrite it using a do-while loop, and it begins with do and an open brace. Inside we have the comment, let the user make a guess. System out println guess, and then below that guess equals keyboard next int. Now a comment, if the user 1, tell him her. If guess equals magic, open brace, system out println right. System out println magic plus is the magic number, and then a closed brace. Unlike before, since we're going to test at the end, we need to put this in here after the guess is made so that it works correctly. Now we have the comment, let the user make another guess. Presumably the guess was wrong. Else if guess is greater than magic, system out println wrong, too high. Else system out println wrong, too low. We then add one to tries by writing tries plus plus semicolon. We have a closed brace, and then while guess is not equal to magic. This would be the alternative to the loop that we have in the program as we wrote it earlier.